Welcome to another edition of TRANSLOGIC. I'm Bradley Hasemeyer, and this is Caitlin Thompson.
Thank you, Bradley. On this episode, I head back out to meet some of the world's leading up-and-coming auto designers and get a crash course in becoming one.
And minds will be blown when we head out to Detroit to get a demo of Honda's new personal transport device, the U3X. But first, it's time for the TRANSLOGIC World Report. On today's World Report, we're going to be doing a quick roundup of some tiny electric cars making big waves. First up is the Mini E. Recently, a race-equipped version hit the famed Nürburgring in Germany, and it made it around the 13-mile track in a respectable time of 9 minutes and 51.45 seconds, hitting a top speed of over 116 miles an hour. It's about a minute slower than the Cooper S, but it's electric, which is awesome. Now, granted, this Mini E did shed some 400 pounds, had improved aerodynamics and racing brakes, but still, it's a pretty solid time and a great sign of things to come.
Next up is an electric version of the super tiny Smart for 2. They developed 100 electric prototypes and set them loose on the streets of London back in 2007. Building on that technology and customer feedback, they are now moving forward in developing a lithium-ion powered smart car, which will be available in 2012. The brand started out hot here in the US, but there are reports that sales have been lagging as the novelty has faded. While the current edition of the gas-burning Smart is tiny, it's still less efficient than the Ford Fusion Hybrid and Prius, and those cars, they also come in grown-up sizes.
And 4 doors, which is easier.
That's for grown-ups.
Yes.
Roger Penske and company think that the electric version of the Smart will get them on track.
Well, we hope, that's for sure. Well, finally, let's look at the EV version of the Fiat 500. The regular version of this car took Europe by storm, but Chrysler's recently announced plans to release a lithium-ion powered version of the ride stateside in 2012. Not only the year the world will end on the Mayan calendar, but also the year we'll all finally get electric cars.
Earlier, I checked out the Art Center College of Design in Pasadena and got some insight into the future of the auto industry. While I was there, I also got to see if I had what it took to be a car designer. Turns out I do. Check it out. I'm here at the Art Center College of Design with Richard Petruska, and you're a faculty member here. What do you specialize in?
Teach beginning transportation design and visual communication, which is sketching and drawing.
And what do you think some of the best and worst designs out there on the market?
That's a difficult question, and the only ones I can think of right offhand would be like the Aztec and a couple of the Chrysler cars. Everybody seems to have something that's a little bit off base.
What do you think it takes to get a design out to the market?
I think in order for the design to get out there, it needs to be a very unique solution to the problem at hand. We're trying to get into the phase where they're working on all kinds of different aspects of contemporary design, whether it's sustainability, new materials, new processes, and things like that. The aesthetic part, we're always looking for new directions in aesthetics and proportions. Automobile proportions are one of the more difficult things to achieve, are good proportions in a new design. But innovation in shape and the technology seems to be the latest thing.
So, Richard, I've always wanted to be a car designer. Do you think you could give me a crash course?
Yeah, for sure. Okay, Caitlin, here's what you need to do.
Okay.
We have to just start fairly simple. There's a number of ways to start designing a car. You deal with proportions, and then you start putting in some of the basic elements form-wise, environments, seating, indicating some doors, window areas. The silhouette is most important in some cases, so that's what we work on. All right, you think you're ready?
Yeah. Wheel. You said the key is to keep moving, right?
Keep moving, keep flowing. That's good.
I'm flowing.
Nice curvatures on your fenders, on the windows.
That's a big window.
There you go.
But that's my design.
And your doors are where? There you go.
That's the big door.
Okay, your taillights.
Oh, yes, yes. Very good.
And the name of this vehicle?
Caitlin 2000. What do you think?
Great, fantastic.
Do I have
you should
future?
sign up for Art Center, I think.
Well, I thought, could I pass with this?
Of course.
I need a little more. All right, here it is. The Caitlin
Fantastic.
2000.
All right.
Coming to you in 2012. Thanks so much to the good folks at the Art Center College of Design in Pasadena. I had a great time.
Yeah. Now, this month, we've been focusing on some of the incredible ideas coming out of the Honda Design Lab. But we also went to Detroit to check out Honda's U3X. Using a lot of the same tech as the Osmo robot project, the U3X is a personal transportation device unlike anything you've ever seen.
Honda studies and researches robotics with the ultimate goal of developing technologies that are useful to people in society, especially in the area of mobility. What they wanted to do here was develop a minimum size type of mobility that could navigate easily in a human environment, but would not put pressure on people. It would be very small, compact, just very easy to use, and it would be at a ride height that is very comfortable for people around it. As far as applications, one could be at a museum, could be shopping, a shopping mall, maybe a next generation wheelchair where you don't have these big cumbersome wheels to turn, but rather perhaps it's a joystick or leaning from side to side. Within very small radius, people could maneuver. The wheel system consists of one large ring or wheel, and around that bigger wheel are small wheels, go all the way around the ring, but they are at a 90-degree angle. So when you want to go forward or backward, the big wheel turns, and when you want to go sideways, the smaller wheels, which are facing sideways, actually move in that direction. For diagonal movement, both these wheel systems operate at the same time. It can actually balance itself. Pretty much just like a human being, as we stand in place, our body is constantly recalibrating where to get our balance, and we're pressing off our toes, the back of our heels, and things like that. The system works pretty much in the same way. If you set up the U3X by itself, you can see the little movements it's making from side to side or forward and backward. It's sort of recalibrating it by milliseconds, its position. Probably the biggest and most attractive feature is the fact that you can move in any direction you want, 360 degrees, just like human walking.
Thanks for watching. That's all the time we have for today. I'm Bradley Hasemeyer.
And I'm Caitlin Thompson.
We'll see you again next time.